Hello folks, I'm Anil, software engineer at Couchbase, and it's great to meet you friends. So this is the wrap-up session for the systems engineering track. And I think what we're going to get started with is a very, let's start with. So how has your experience been with Rootconf in general before? And what would you say was your highlight of the day in terms of the talks that you've seen of people that you met?
I'll go first because I have the mic. Cool. So I think this is probably my third or fourth experience with Rootconf, and probably the second speaking session that I had here. Rootconf for me is a place where you can, when you've done something different and you want to talk about it. I feel in India, Rootconf is that platform, right, where people with kind of a similar mindset come together. They understand the challenges that you're talking about, and you kind of feel that you can that they can take that as a feedback to the as a takeaway, right, and kind of use that in their problems that they're facing, right. And I think apart from that, today for me the highlight of the day was I met close to 15 to 20 people with whom I had worked long time ago, meeting them after probably in some cases a decade and in some cases like few years, and just kept reconnecting with them. And that's probably like the essence for me, the Rootconf, right? Like you get to meet people again with whom you know who are there at a distance, but then this kind of gives you the platform where you can kind of reconnect.
Lovely to hear.
So this is probably my third Rootconf perhaps. I attended some of the really old Rootconf events maybe in 2016 or something, because one of my really old laptops, right, it still has the Hasgeek sticker on it,
oh,
which I noticed sometime back, right? The road to Rootconf, I would say, was very detailed, right? I mean to say the amount of due diligence, especially all the editors and the committee which was managing the entire thing, right, was like really impressive. I would say they ensured that every small detail is sort of picked out and supported the speakers really well, giving them a lot of feedback on what to improve and how to engage the audience and all of that. So that was like really good. And multiple talks in today's event were really interesting. Multiple talks, it could be right from Amod's keynote talk to the whole ISDB story and a couple of the talks. But really, I mean, you would really want to think how people are thinking about this whole solving the problems in their own world. So it's a really informative sessions Rootconf this year.
Awesome. Yeah, I think a lot of very interesting topics that you usually find.
Sure. Yeah. So for me, it was quite a journey, right? So I kind of started as a speaker a few years back, right? Rootconf, and then this year I got to switch sides on the table, and I was an editor, essentially curating these talks, right? So that experience has been interesting and like very fun as well. Like I worked with a bunch of people that I've known in the industry but hadn't really had the chance to work with. Both the people that were curating the talks with me as well as the people who were submitting these submissions, right? One thing that I particularly like about Rootconf in general, not just like this mini particularly, but there's a feedback cycle, right? It's not a black box. You throw some content and someone just sends you a mail that sorry, this year you're not going through, or yeah, congrats, you're going through, right? Something like that. So there's a constant feedback cycle. People actually want to understand what the speaker wanted to propagate as their vision for the talk, right? Sometimes people may or may not have the write it out, but when they explain it verbally, for example, the things change. So that I was able to be on the other side of things and also understand how people try to communicate as well. So that whole journey for me has been interesting. As an editor, I mean, highlights for the day for me would have been like the fact that the talks ended up being interesting for the audience as well, right? As much as we found them. I'll wait for the true feedback to come from the audience, but I hope that they actually liked it. That's pretty much it.
Okay, let's have a quick preview. We'll have you folks introduce yourselves as well, because I realized that we forgot.
So I'm Ayush. I work at CRED. I handle everything cloud and data security at CRED.
Awesome.
Hi, I'm Aryan. I'm working as senior principal architect at ShareChat. I'm the overarching architect for the company.
I'm my name is Vaidyanathan, and working in Flipkart. So I work as a senior engineering manager there, and my team basically manages all of the databases in Flipkart.
Awesome, lovely to hear. So yeah, so we've covered general highlights for the day, and I got to hear about your story with Rootconf, which is very refreshing. This is my first Rootconf, and I've had a lovely time so far. So given that, so in the time I've spent here today, there was a really lovely systems engineering time, which as a systems enthusiast, it's very nice to see a lot of systems people congregating in one place and talking about actual problems that they're running into. Right? So I think looking at where the ecosystem is headed today, we all know that there are obviously very critical systems that underlie most of the work that happens today. Be it databases, be it compilers, be it browsers, be it kernels, operating systems, right? These are all very critical systems. But given that systems don't get as much of the limelight as some other domains do get nowadays, right? I was recently a college student, so I've been out of college for about 10 months. And what I've realized is it's really hard for freshers, or beginners at least in that sense, to get started in systems. Because the shiny example of a good system is something you'll probably see, like engineering talks on that Facebook is like, okay, we built a load balancer for a billion scale, right? Or you see blogs from Netflix about Chaos Monkey, or all these really complicated fancy things, right? And that makes you look and say, okay, cool, I want to do systems too. But as a fresher, it's incredibly difficult to get started from getting your hands dirty. So, given the experience that you folks have in this, what would you say is a good way for freshers to get their hands dirty, or for people who are newly interested in systems to get their hands dirty? Because not all of us can build an entire database, an entire compiler on day one. So, what would you say are a few good steps in that direction for people who want to get their hands dirty in systems?
So I think fundamentally you're right in the sense, right? Like there are some topics which get a lot of more interest than some of these topics, and there's no other way to say it, right? Like that's just how it is. And somehow a lot of the people who are sort of graduating, they're also somehow mistakenly thinking that that is the only cool thing and that's the only thing that they want to do, or things like that. Right? But there's a lot more that is happening beneath that, the kind of thing that is powering that, which is, I would say, far more important to sort of understanding one's career, right? Like, this is not the only thing. So my tip for anyone who wants to sort of understand systems engineering and everything is fundamentally to be curious, right? So I would advise pick any system that you are aware of, any database or any, it could be Redis or it could be MySQL or it could be anything for that matter, right? Pick that one database and just try to understand what was the thought process of the person who designed it, and then subsequently try to just go a little bit deeper into the database, or any system for that matter. It could be anything, it could be Kafka, it could be anything. Just pick one system, try to go a little deep into it, and automatically the interest develops, I believe, and that's a really great starting off point. Just to understand first before you contribute and all of that. Understanding and getting interest.
Slightly adding to that as well, I think one of the core problems that I have with a lot of these youngsters that who have taken up computer science, but are focusing so much on the application and like on the shiny side. For example, you have these courses now that only is teaching about data science, right? Who are actually now teaching, hey, how do you build agentic AI, right? And if you just reflect back to what Amod said in today's keynote, right? Everything boils down to fundamentals, right? You may be working on the web browser, back to the database. If you focus on your fundamentals, you will understand how to build something, right? And like abstraction of an operating system, abstraction of a browser, abstraction of your application revolves around those fundamentals, right? So the problem I see, and therefore the tip I would like to give is that while it is good to get trained on some of these high level things, high level abstractions, it is far more important to have, right, in your company or wherever you're working, figure out how you can go and gravitate yourself towards the platform horizontal kind of problem statements. Because that is where you will not narrow your thought process early in your career into a very specific vertical problem statement, right? And that therefore helps you create that, gets you, get into an ecosystem of curiosity-led, problem solving, right? So think about how you can build more platforms and get that platform thinking, and things will then start falling into place.
So by platform here you mean the underlying infra that supports the work?
It could be different for different types of what domain vertically you're in.
Okay.
Right?
Okay.
But platform essentially means that, I'll give an example, and I recently met Richie, who's the founder of Bobstream, which recently got acquired by Kafka. Now how that guy started his journey was, he was in Datadog, right? And his problem statement was, how do you scale Datadog's infrastructure of, and they were on Elasticsearch back then when that initially built the system. So they were trying to build the best search capability and scale it, right? Now he was therefore in an application domain working with databases. Now his problem statement was, how do I get 100x of what we are able to currently do? And that led him to build solutions, expand the thought process of how to do this at a much lower scale, much lower cost, but at a much higher scale, right? Therefore, he was in that, even in a very specific company, but he was working on the horizontal side of problem statements, right? So you may be in different domains, but try to attach yourself to problem statements that are horizontal in nature, that requires specific understanding of patterns and problem statements, and a lot of things you will learn with people whom you are working with. A lot of things you will learn, you will be able to use by having applied your fundamentals really well, right? And he built whatever learnings he got from building that system. He developed that into his own company, Wobstream, which has done really well, and then got acquired by Kafka Conference
for a couple of $100 million.
Yeah, right. And all that done, and he's, I think, maybe 2-3 years out of college.
Yeah. He's a fairly young.
Yeah.
I met him recently. I had the opportunity to meet him recently at a meetup.
Okay.
And it's very interesting how they were able to apply a lot of fundamentals, right? So a lot of interesting points in the Wobstream architecture that take you back to fundamentals.
Exactly. That's my point, right? He was a platform, and in fact, we speak to him, he said that, hey, he talked to a lot of our engineers, said that, don't worry about trying to understand domain, right? Gravitate towards platform problem statements. You will naturally be able to develop a horizon, and that leads back to systems engineering track, right? That will lead to creating core fundamentals, expanding your understanding of core systems, and then through that you can then build your own set of domain-specific solutions.
Ayush, what about you?
Second, basically what these guys said, right? Curiosity is of course important, right? There's n number of abstractions. Like every day there would be, a new tool, a new platform, or a new something would come up and abstract away some complexity, so that you can click a few buttons and then you're done with something, right? But that shouldn't make you, shy away from the fact that you need to understand what's happening beneath, because when things go wrong, you wouldn't really have the ability to solve for it regardless, right? And the only thing that I can probably add is engineering, most other things, is building muscle memory. The more problems that you solve, that basically was what he was essentially saying, right? Solve problems that are horizontal in nature. The more problems that you'll solve, the muscle memory that you'll build up on, okay, I've encountered this before, right? Will enable you to solve things faster and build more complex and complicated system with ease, without realizing that you built something very complicated with the ease of because that experience accumulated and you've solved something critical for your organization or something like that.
Awesome. So yeah.
There's another observation, right? I think in today's your generation, right? I would say a lot of you. So a lot of you probably have laptops, right? MacBooks or laptops or whatever, right?
Yeah.
A lot of, in our generation, right, a lot of us, that's the way to put it, right? We had desktops, right? And we used to configure our own CPUs. We used to get our hands really dirty as a motherboard, plug in the RAM or whatever, right? Actually plug in those things and then understand what is going where, why is it going. If I need to increase my RAM, I would actually go purchase something and then I would figure out where it fits, and sometimes it doesn't fit, and then
Most painful experience.
It's painful experience installing your operating system on the thing and all of that, right? So I would say a practical tip for people to sort of get comfortable with this whole thing is don't buy laptops, right? Buy good old desktops, configure your own CPUs, install Linux if you can, get comfortable with that world, and then automatically things will start flowing, right?
Yeah.
Don't go for MacBooks with everything pre-created and all of that. And the problem is, if you want to experiment around with something, it's not that you have to purchase some cloud, you have to purchase some, go to a cloud and then get some VMs and stuff like that. You can very well do it on your own system. So yeah, that's another practical tip.
I think a big moment for me, which is basically how I got interested in systems, is that I decided to install Arch. And it was, and in general, dual booting teaches you so much. Like, it's a very underrated way of learning how your system works. The side effect is that you're going to have to learn, regardless of whether you want to or not, if you want to do the dual boot. But it's a great experience. So quickly, in maybe like a few words, if not for dual boot, from a code point of view, what would be a good small project to get your to peel away maybe one layer of abstraction? Because I asked this question to a few folks before who I met, and one bit of advice was try and implement a shell or a basic wrapper, so you get some idea of what the syscalls are, how that works under the hood. So I would be very curious to hear your inputs.
I think there are enough projects, right? I would say. In fact, I would endorse it today. This talk was there about ICDB. I would say even try understanding first, what is the perspective, for example, why ICDB was built, what is the context of what is building, right? And just start contributing to that, right? And even something as simple as that, when you start going through the code, you sort of understand a lot of the semantics, I would say, right? And that's a great place to start. So definitely I would advise somebody to do something like that.
I think what I typically do is, depending upon what technology that I'm working in, most of it is open source. I start going through the code, right, and understanding, and then having that run locally. And through that, you start understanding, right? For example, if I talk about Kafka, right, like they talked about how they used, how the entire architecture was built, right, and then how they went about, solving for performance issues through their through the technology stack that they built, right? So like all these things starts teaching you, like when you start going through code, you start understanding, you build understanding of how consumers are consuming the data, how they're interacting with disk, etc. Right? So generally this is what I do, right? I don't know whether it kind of works because I try to learn something in the context of what I'm building, right? Now, only when I'm because I'm already kind of working somewhere, the time that I get for my learning is basically through the work that I am supposed to do in my day-to-day life, right? So therefore, I don't try to distribute my time so much that I try to learn something which is good, which has maybe a parallel knowledge kind of group altogether. But in the context of what I'm trying to do at that point in time, I try to kind of understand its patterns, and through that, and having spent different amount, having spent a lot of time across different spectrum of applications, like web applications, databases, your entire data warehousing world. That is how my learning has evolved over time. But this is what I do. I don't know whether it works for everyone or not.
Very useful advice, for sure.
Yeah, essentially the same, right? You'll have to have some kind of inclination or incentive to put that effort in towards learning. So it will have to be something that you do want to learn in the first place. Sometimes it's not an option if you're solving a problem, for example, your company, but typically it has to align somewhat to your interests as well. So, for example, I learned about Linux, the hardware, because being a security guy, I installed Linux, and it has a constant habit of breaking, right? So much so that even most of the time I was in the debug mode, doing manual mounting and everything. So that was my journey into learning. Okay, there is a command thing called command line, which you can pretty much, or almost everything you can imagine that you can do on the GUI, sometimes more. You can do on the CLI as well. So maybe also put yourself in uncomfortable positions, maybe willingly at times, that you're forced to learn stuff as well. That could be a thing.
Yeah. Okay. So getting to our, I don't want to keep you guys. So getting to our last question, right? I think what we've understood so far is that there are two parts to systems. There is curiosity that you need to learn, to try and understand how things work, and the second one is a mindset question. Right? So you need to, or it's ideal rather, that you have the mindset that nothing is a permanent black box. Right? It's all code at the end of the day. It is complicated, it's convoluted, but at the end of the day, it's code. Right? So, I think systems puts you in a mindset where you're willing to say, okay, I know this is the interface. I want to find out what's going on underneath the hood. And I think that that's a massive advantage. So, which leads me to my next question. Right? What are some really interesting problems that you folks have done that are maybe on the system side that you would like to maybe talk about? That really push the point forward. That it's a question of mindset. And you have to be willing to peel a layer or go back to understand why it's a problem.
I think my greatest learning, because my entire journey has been through all the production incidents that have happened over time. Right? The most exhausting one was during one of the BBDs. I was in Flipkart for about 8-9 years. Our entire Kafka cluster was down during BBD for about 2-3 days.
Oh, that's
right?
bad.
And I spent about 72 hours in office trying to solve. Right? And when we started understanding where it is breaking, right? Being able to dissect from an application stack which is interacting with Kafka to Kafka interacting with this, right? And then the failure of machines, right? Hardware has a certain rate of failure, right? And that helps when, for example, from a disk perspective, it goes through enough cycles of usage to ultimately start breaking, right?
So these are SSDs, is it?
These are, I think we were using HDDs back then.
Okay.
It's about 7-8 years ago.
Okay.
We were on spinning disk, not SSDs. So, point being that my entire learning, those 2-3 days of exhaustive experience was created this entire, I had to go down to understanding how things work at a hardware level, to be able to then map it back to the software stack having those problems, and then being able to recover data, etc. Right? How do you recover all the data? So it's, for me, it has always been very experiential based learning that I've always enjoyed, and most of my learning spikes have been around incidents, debugging those incidents, and figuring out how do I come out of that.
Are you at liberty to share what the actual issue was?
If I now recollect, it was basically very high disk IOS pressure created by a consumer application who was trying to read the data, and we realized that Kafka had a bug where we felt that the data would load into memory and then serve, but actually it was directly being served out of disk, so which led to huge disk IOS pressure. That created a chain of events which led to the multiple disks across multiple nodes failing, right? Because it kept right, and then the Kafka cluster reached a state from which the entire cluster became unrecoverable. Right? So
amazing. So you found, is it fair to say that you found maybe a non-optimal way of doing things in code that you would otherwise rely on?
Non-optimal way of doing things. I think probably our question was that how my learning from that particular incident was that how you think something is not really increasing the rate of consumption from in this example, this is the Kafka cluster, and in fact why it increased was that we missed a configuration where we were not compressing the data while producing it, and that led to huge apps while producing, but at consumption layer, because there are multiple consumers, it increase the pressure even, right? So like missing the change that hey, this configuration could lead to a chain of events, right? And then hardware also was feeling at a much higher rate because of the amount of work that it had to do, right? Like a small miss, right, led to an entire stack of problem statements, like understanding of the hardware level, plus Kafka not being able to get that in because it was a big block of memory that it needed to read. It skipped memory, like it skipped the in-memory load. It directly was serving out of disk.
Okay.
That increased the disk pressure again, like on the consumer side. Right? So,
right.
So like so my learning is around it how like small changes, right, can create big ripple effects.
Yeah.
Around.
So I largely look at databases in Flipkart, right? Of course, like I speak in area also. I mean, a lot of the learning happens on production incidents nowadays, where there's a lot of pressure as well to figure out what's happening. You mitigate it. You also need to figure out what is causing it, and also propose a long-term fix for it. Right? So these are some of the really good learning opportunities that we get. Particularly speaking, maybe I can recollect in sort of recent memory one of the incidents which happened in the database world, right? So we had a MySQL cluster, and then we have our on-prem, right? So hardware does keep failing every now and then, right? So there was this team which was saying that half their data is missing, right? So we started asking them, is it, what about
very scary?
Yeah, it's very scary, right? Yeah. And they said half. So
yeah, even more scary.
Even more scary. half is there. So we told them, okay, fine, you should be getting those errors, and with what about the retry and all of that. And they go and check, there are no errors at all. There are no errors, everything is fine from the application side. Half the data is missing on the database, and there's nothing really happened over here. Eventually turned out that this whole scheme of things where you have a DNS and all of that, and there was a promotion of a master. The master failed, a new master came on. But for some weird reason, the old master also came.
Oh no, a split brain.
It was a split brain scenario.
Wow. Okay.
First time on production, sort of a thing, and it happened because of a network switch. So the compute itself had not gone down, but the network had gone down through the compute, and when the network went down, he couldn't really kill the old man. And then when the network came back up, that guy also came back up, and due to connection pooling, some of the connections were still talking to the older endpoint which was resolved.
Wow. Okay.
So in a connection pool, for example, there were 100 connections. 50 of them were talking here, 50 of them were talking here. So eventually we stopped the old guy and copied all the data from there to here. And it was a lot of difficulty to recover all that data. The IDs were generated and all of that. But then it was a lot of fun working with the team to debug that.
Of course, I imagine that's quite the hallowed story of no, because split brains are extremely rare, right? They're not supposed to happen, and most protocols are designed against them. So it's very cool to hear that you survived a split brain incident. Yeah. Yes. So over to you, Ayush.
Okay, so one more way of inducing learning is, if not production issues, find a problem statement that is not solved or very well documented to solve for. One of them, which is what I'm currently working at Cred, is data security, right? So there's multiple layers to this problem, right? First of all, you need to figure out what do you have in the first place, right? We, for example, have a bunch of LOBs, lines of businesses, right? So we have people's, let's say, credit score, their names, addresses for sending them stuff, right, and stuff like that. A bunch of them constitute PII, some of them do not, some of them in conjunction constitute PII. But
PII is
personal identifiable information, right? So because of that, you will say it's a simple problem. Okay, wherever there is PII, just go ahead and encrypt it, mask it, do something about it, right? But where is it? Is the hard part of the problem statement, right? Because data doesn't just reside, for example, in your databases. That's typically your source of truth for most cases, but for example, for eKYC stuff, sometimes pictures are taken for your PAN, so it might be an object in an S3 bucket, right? And then people for analytics or machine learning will pool that data, put that in a warehouse, let's say Databricks or some other place, Snowflake, right? put their analysis, make copies of the same table with now their specific fields that they want to work on, and then the same one person's name is now in 20 places that you have to find it and solve for it, right? And this is just the first leg of the problem, because unless you have visibility, you can't do anything. For example, if you go to Google or Facebook, you can probably ask them, not probably, you can ask them, please tell me what all data do you have about me, right? They'll send you a consolidated list of things that, hey, but this is all the things that we have for you, right, of you. Now, again, it seems like a simple problem. Okay, wherever there's a table called, for example, users, just do a search for hey, wherever user is, I use, just tell me what you have about it. But because of this replication, and then the replication of the data within the same data store also, right, it becomes challenging to map it across your data universe, across different types of data stores, all of them having different settings and everything, right? So suddenly, this simple questions that compliances require you to do become a very complicated process to solve for holistically, right? You can pick one system in isolation and probably solve for it end to end, but it still wouldn't really be compliant in that manner, right? So that's one of the cool problems that I'm working on right now.
Awesome, great to hear. And I think with that we can wrap up our wrap-up session. So it was great meeting you folks. Thank you so much for taking the time to address a lot of the maybe junior folks around my age who will be watching, and everyone else as well. Your advice has been very valuable. So thank you.
Thank you.